and today I'll be presenting the Agora Math Circle 2019 AMC 8 solutions. Problem number 1 states, Ike and Mike go into a sandwich shop with a total of $30 to spend. Sandwiches cost $4.50 each, and soft drinks cost $1 each. Ike and Mike plan to buy as many sandwiches as they can and use any remaining money to buy soft drinks. Counting both soft drinks and sandwiches, how many items will they buy? So in order to solve this problem, we first need to come up with the equation of 4.50, because that's the cost of one sandwich, S, which stands for sandwich, plus $1, because that's how much one soft drink costs, and D for drink, all equals to $30 in total. Now we want to find the maximum amount of sandwiches that can be bought. So we have to find the maximum amount of times $4.50 can go into $30. So using some calculation, you can figure out that $4.50 times 6 equals $27. And since you can't go to 7 because then it'll be $31.50, you must stay at $27 with 6 sandwiches. So if you have 6 sandwiches, that's already $27. So that's 6 items so far. Now I have to find out how many drinks you need as well. So $30 minus $27 from the sandwiches equals to $3. So you have $3 left. Now, $1 1D equals to 3. So by calculating this, D equals to 3. So you get 3 soft drinks. So adding 6 and 3, you get a total of 9 items, which gives you the answer of letter D. Problem number 2 says, 3 identical triangles are put together to form a rectangle ABCD, as shown in the figure below. Given that the length of the shorter side of each of the smaller rectangles is 5 feet, what is the area in square feet of rectangle ABCD? So in order to solve this, we know that the smaller side, which is the shorter side, is 5 feet. And we know that in order to solve for the area is length times width. So in order to get the length and the width, we need the length of the longer side, which is highlighted in green. So in order to find the length of the longer side, you need to make some connections first. Here we have 2 shorter sides that are both 5 feet. Now added together, they reflect directly across, and 5 plus 5 equals to 10, which means that the length of the longer side is 10. Since the length and the width, the corresponding lengths and widths should be equal to one another, since the rectangles are all equal. So knowing this, we know that the length of the longer side is 10. So we have our width. Let's assume this part is our width and this is our length. Now that we have our longer side, we can assign this value to other portions. So we would know this green part over here is 10 as well. And the smaller part over here, which is 5 feet, since it's the shorter side, would be 5. So 10 plus 5 equals to 15. So now we have our length. So our length equals to 15, and our width equals to 10. So if you multiply these together, you get 150 as our area. So 150 feet squared, which gives you the answer of letter E. Problem number 3 says, which of the following is the correct order of the fractions 15 over 11, 19 over 15, and 17 over 13, from least to greatest? Now in order to solve this, you could use the more complicated method, which is actually getting all the denominators to be the same and then comparing the fractions. But that would take a lot of your time. So an easier way to do this would just be to realize that 15 over 11 can easily be converted into 1 and 4 11s. 19 over 15 can be converted into 1 and 4 over 15. And then 17 over 13 can easily be converted into 1 and 4 over 13. So if you know enough about fractions, you would know that the larger the denominator is, the smaller the fraction would be, because it's a smaller portion of a larger part. So that would mean that this would be number 1 in the order, because it would be the smallest. And then this would be number 2, because it has the second largest number compared to 11. And then this would be number 3 because it has the least denominator among all of these. Because the greater the denominator, the less the fraction the less is the value of the fraction. So using this information, we can order these so that the answer would be, your final answer should be 19 over 15, comma 17 over 13, comma 15 over 11. And using this order, you would get yourself the answer of letter E. Problem number 4 says, quadrilateral ABCD is a rhombus with perimeter 52 meters. The length of the diagonal AC is 24 meters. What is the area in square meters of rhombus ABCD? So if you know about geometry, you should know some of the basic equations. One of them being the area of a rhombus, which is area equals to PQ over 2. Q is the diagonal, which is AC in this case, and P is the other diagonal, which is BD. So we need to find out what BD is. So that's what we're trying to find right now. So in order to solve this, we know that since Q would be 24 meters, let's make up an imaginary point. Let's say the point where P and Q intersect is point E. So AE would be equal to EC because these parts should be equal. So because of that, that would mean that AE has to equal 12. So let's use this triangle for a moment. So we have 12 over here. Now, we don't know what P is, but we don't know what half of P is, but we can find out what AD is because in a rhombus, we know all the sides have to be equal. So if all the sides are equal, there's 4 sides, so we do 52 divided by 4, and if you solve that out, you get 13. So each side is 13. So now, here we have our shape. And I know my drawing isn't accurate, but this is supposed to be a right angle because it is going straight down since the points have to be directly across from one another. So because of that, we have 12 squared plus half of P, which is P over 2 squared, equals to 13, which is the Pythagorean theorem, which is another useful equation to know. So knowing that, we can do 12 squared plus P over 2 squared equals to 13 squared. And 12 squared is 144 plus P over 2 squared equals to 13 squared, which is 169. And using that information, we know P over 2 squared equals to 25. So P over 2 equals to 5, which would mean that using this information, we can multiply both sides by 2, and P equals to 10. So now we know what both Q and P is. So we substitute it into the equation, and we get the area of this rhombus equals to 10 times 24 all over 2. That's 240 divided by 2, which gives us the answer of 120. So our area in square meters is 120 square meters. And using this, we can get ourselves the answer of letter D. Problem number 5 states, a tortoise challenges a hare to a race. The hare eagerly agrees and quickly runs ahead, leaving the slow-moving tortoise behind. Confident that he will win, the hare stops to take a nap. Meanwhile, the tortoise walks at a slow, steady pace for the entire race. The hare awakes and runs to the finish line, only to find the tortoise already there. Which of the following graphs matches the description of the race, showing the distance D traveled by the two animals over time T from start to finish? So, we should all know that the equation for speed is distance over time. So in essence, this is basically a graph of the speed of the hare and the tortoise during the race. So we're going to use pink for the hare and green for the tortoise. So we start off with the hare going ahead, right? But then it says the hare stops to take a nap. Now, when the hare stops to take a nap, that means that there's no change in speed. So it would just be a straight line across. And then we have the tortoise. Now the tortoise we can easily mark. There, it's consistent throughout the entire race. I know that's a wobbly line. Sorry. And it's supposed to be straight. But for the hare would be over here, like this. It would be ahead of the tortoise's line because, as you see, it would come after the tortoise. So the tortoise would have a shorter time than the hare. So if you look down, if you go directly down and match it down, this would be like about the time of the hare, and then this would be the time of the tortoise. So the tortoise would end earlier than the hare, which means that the tortoise has won the race. And since the hare stopped to take a nap, but the tortoise is continuously going, we would be left with this graph, which accurately depicts the race. And using this, we can get our answer of the letter B. Problem number 6 states, there are 81 grid points uniformly spaced in the squares shown in the diagram below, including the points on the edges. Point P is the center of the square. Given that point Q is randomly chosen from among the other 80 points, what is the probability that the line PQ is a line of symmetry for the square? So as we know, Q could be any of these points over here. And the line continues on infinitely. So if Q is over here, the line would continue on forever either way, completely cutting this in half diagonally. And first of all, we need to evaluate the different ways that the square can be symmetrically split. So the first way is straight down, second way straight across, third way diagonally from the left to the right, and then the fourth way diagonally from the right to the left. And that's 1, 2, 3, 4, 5, 6. So that's 6 ways. So there are 6 ways to split this square evenly using a line of symmetry. Now, knowing this, we can evaluate one of these methods. So let's say we're evaluating the directly vertically down method. That would be 1, 2, 3, 4, 5, 6, 7, 8. 8 possibilities in total. And since this is 9 by 9 square, the same thing would apply for horizontal. It would also be 8 possibilities. And then diagonally, 1, 2, say like this, it would be 1, 2, 3, 4, 5, 6, 7, 8. Another 8. And then same thing for the other diagonal. And then, now that we have 4 8s, we add them all together to get the total number of ways we can divide this using a line of symmetry. And 4 times is basically 8 times 4, which is 32. Therefore, if we multiply this out, we get 32 total ways that we can get this. However, this is asking for the probability. So what is the chance out of the rest of the points? So since there's a total of 80 other points to choose from, you do over 80. And you simplify this fraction to get 2/5. And that's your answer, which is letter C. Problem number 7 says, Sean takes 5 tests, each worth a maximum of 100 points. Her scores on the first 3 tests are 76, 94, and 87. In order to average 81 for all 5 tests, what is the lowest score she could earn on one of the other 2 tests? So in order to solve this problem, let's assign the first unknown test as x and the second unknown test as y. So 81 being the average, we would get the equation of 76 plus 94 plus 87 plus x plus y all over the number of tests she's getting, which is 5, should equal to 81. Now, using this information, we can calculate. So we can reverse to find out what x plus y is supposed to equal to. So we can do 81 times 5. 81 times 5, as you should easily be able to do, is 405. Using that, we would know that this entire sum is equal to 405. So with that knowledge, we know that if we subtract these 3 numbers from 405, we would get what x plus y is. So these 3 numbers all add up to 257. So So 405 minus the sum of these three numbers, which is 257, gets us the number of 148. That means x plus y equals to 148. But we're not done here. We want to know what the lowest score she could earn on one of the other two tests is. If the maximum score is 100 points, we subtract 100 from here to get 48. So 48 is the least possible score that Shauna could be getting. So therefore, 48 is your answer, and that gives you letter A. Problem number 8 states, Gilda has a bag of marbles. She gives 20% of them to her friend Pedro. Then Gilda gives 10% of what is left to another friend, Ebony. Finally, Gilda gives 25% of what is now left in the bag to her brother, Jimmy. What percentage of her original bag of marbles does Gilda have left for herself? So, in order to solve this, a lot of these kinds of problems typically pop up in AMC 8, and the way I would solve it is just assume that she has 100 marbles. It makes it way easier for you. If you assume Gilda has 100 marbles, then if she gives 20% of that amount to her friend Pedro, she's giving away 20 marbles. So minus 20 is 80. So we'll label this step Pedro. Then she's giving out 10% of what is now left to her friend Ebony. And 10% of 80, as we all know, is 8. So we subtract 8 and we get 72. And I'll label this step Ebony. Or Ebony. I don't know how to pronounce this. And I'm sorry for the awful job. Okay. And then we have 25% of what is now left for her brother, Jimmy. So in order to solve this, we need to find out what 25% of 72 is. And that's basically what 1/4 of 72 is. 72 divided by 4. 18. So we subtract out 18. And once we do that, we are left with the number 54. And that is the amount of marbles she has left. 54 out of 100 marbles in the beginning. So that's 54% of her original marbles. And using this method, where you start off with just 100 anyways, is really helpful when calculating these kinds of problems. So with this answer, 54%, we get our answer as letter E. Problem 9 says, Alex and Felicia each have cats as pets. Alex buys cat food in cylindrical cans that are 6 centimeters in diameter and 12 centimeters high. Felicia buys cat food in cylindrical cans that are 12 centimeters in diameter and 6 centimeters high. What is the ratio of the volume of one of Alex's cans to the volume of one of Felicia's cans? So in order to solve this, you need to know the basic equation for the volume of a cylinder, which is 2 pi r times height plus 2 pi r squared. So, basically, most of this problem is just substituting into the equation. So, we all know that 2r, so 2, the diameter doubled equals to, the radius doubled equals to the diameter. So, that would mean we have to divide the diameter by 2 in order to get the radius in both of these cases. So here, let's solve Alex first. So, Alex, right? Her diameter is 6 centimeters, so her radius must be 3 centimeters. And then, we also know the height of her can is 12 centimeters. And we substitute it in, so we get 2 pi r, so we'll substitute that in with 3 times 12 plus 2 pi 3 squared. And solving this entire thing out, you would get 54 pi plus 18 pi, which equals to a total of 72 pi. So that's the volume of Alex's cylinder, or can of cat food. Now we have to solve out Felicia. Okay, for Felicia, we have her diameter, as you can see, is 12 centimeters, and half of that would be our radius of 6 centimeters. So r equals 6 centimeters in this case. And then the height equals to 6 centimeters as well. So 6 centimeters. And then when we substitute this in, we get 2 pi times 6 times 6 plus 2 pi 6 squared. And if you simplify this out, you get 72 pi plus 72 pi, which gives you an answer of 144 pi. So that's the volume of 1 can of Felicia's cat food. And then solving this together, we're doing the ratio of Alex to Felicia, so that's A to F. A to F would be 72 pi to 144 pi. And simplifying this out, both these are divisible by 72, so it would be 1 to 2. So that would give you the ratio of 1 to 2, which is letter B on that problem. Problem number 10 states, the diagram shows the number of students at soccer practice each weekday during last week. After computing the mean and median values, coach discovers that there were actually 21 participants on Wednesday. Which of the following statements describes the change in the mean and median after the correction is made? So we know that the mean is the sum of all the factors all over the number of days. So if there's a certain number of days, so there's 5 days in a week, or in this in the logged data, and we have 20, 26. 16, 22, and 22 and 16. So if we have that, we first find the mean of the incorrect data. And using that, we would get that the original mean was supposed to be this whole number divided by 5. So if we add it up, we have 20, 26, 16, 22, 16. 16 and 16 add up to make 32. 32 plus 22 is 54. 54 plus 26 is 80, I believe. And then 80 plus 20 is 100. So 100 divided by 5 equals to 20. So that was our original mean. Now our new mean involves 16 being 5, just 5 greater. So you actually don't have to solve this whole thing out, because if you see, if it's just 5 greater, you just add 1, because it's just 5 over 5 is 1. So you just add 1 to the original. So 20 plus 1 equals the new mean with the accurate data, which is 21. So that's an increase of 1 in the mean. So that leaves us with the letters A, B, and C. Now we have to find the median, the difference in the median. So the original median would have been 16, 16, 20, 22, and 16. Oh, and 26. Sorry, this looks like a 26. Okay. The original median would have been 20, but the new one is, if we put it in the right order, we get 16, 20, 21, 22, and 26. And that's 21 as well, which means that the median also increases by 1, because 20 plus 1 equals to 21. And since both have an increase by 1, we get the answer of letter B, which states that the mean increases by 1 and the median increases by 1. Because as we proved today, the mean increases from 20 to 21, and so does the median. The median also increases from 20 to 21. So your answer is letter B. Problem number 11 states, the 8th grade class at Lincoln Middle School has 93 students. Each student takes a math class or a foreign language class, or both. There are 70 8th graders taking a math class, and there are 54 8th graders taking a foreign language class. How many 8th graders take only a math class and not a foreign language class? So to solve this, we need a Venn diagram. One circle will be labeled math, and the other circle will be labeled foreign language. Now that we have the Venn diagram, this intersection represents the number of students that are in both math and foreign language. So if we add up the values from here, the middle, and the side, we should get a total of 93 students. So in order to solve this, we don't know the number of students that are in both, but we know there are 70 students in math and 54 in foreign language. But some of these students could take both. So if we add this up, we get 124, and that's far from 93. And if we subtract 93, we get 31, which means there are 31 students that are taking both classes. Now, if 31 out of the 70 students are taking both classes, then that means only 39 students are taking only math. And if 31 of the 54 students were taking foreign language, then now only 23 of those students are taking foreign language. And the rest are taking math and foreign language. And so if we add these three up, 39, 31, and 23, we get a total of 93 students. So now it's asking how many 8th graders take only a math class and not a foreign language class. So that would mean we'll be looking at this section over here. And the answer would be 39, which gives you the answer of letter D. Problem number 12 states, the faces of a cube are painted in 6 different colors. Red, R, white, W, green, G, brown, B, aqua, A, and purple, P. 3 views of the cube are shown below. What is the color of the face opposite the aqua face? So with these types of problems, it's more about drawing conclusions based on the information that they give to you. So in this problem, as we can see, they're basically rotating the cube around, but in each one we have red, which means we can use red as a reference. So for this one, red, brown, green. For this one, red, brown. If red and brown are here, then green should be on the opposite side. So you put green there. And then for this one, red, purple, green. If purple's over here, then, If green's over here, then opposite of green is white. So over here is white on the other side. And then, since there's purple over here, we know that what is opposite of purple is brown, because as you can see in this one, brown is above red. So using this information, we can start to piece together. So if that's white, brown, then there's only one color left for the opposite side of red, and that's aqua, A. So A is on the bottom, which means that the side opposite of aqua would be red. Well, that's not red, but still. So that means your answer would be letter A. Problem number 13 says, a palindrome is a number that has the same value when read from left to right or from right to left. For example, 1, 2, 3, 2, 1 is a palindrome. Let n be the least 3-digit integer, which is not a palindrome, but which is the sum of 3 distinct 2-digit palindromes. What is the sum of the digits of n? So 2-digit palindromes include numbers such as 11, 22, 33, and so on until 99. So if we're going to find a number, we need to find a number that's greater than or equal to 100. So 11 plus 22 plus 33 does not work because it's too small. And then we have 44 and 55 as well. But this still isn't enough. But 33 plus 44 plus 55 is enough. But 44 plus 55 is already 99. So if we just want to increase it a little bit, we can just add on the 11 to get 110 as our as the greatest number over 100, which is, as the least number over 100. And this is our answer, which gives us the answer of letter A, because 1 plus 1 is 2. Problem number 14 says, Isabella has 6 coupons that can be redeemed for free ice cream cones at Pete's Sweet Treats. In order to make the coupons last, she decides that she will redeem one every 10 days until she has used them all. She knows that Pete's is closed on Sundays, but as she circles the 6 dates on her calendar, she realizes that no circled date falls on Sunday. On what day of the week does Isabella redeem her first coupon? So whenever we're going through 10 days, it's basically the day plus 3, because there's 7 days in a week, and then you just add 3. So plus 3 is Thursday, and plus 3 is Sunday. So this can't work, because we can't have any of the dates on Sunday. Plus 3, plus 3. Now, Tuesday won't work because, keep in mind, this is 6 different coupons. So, coupon 1, coupon 2, coupon 3, 4, 5, 6. The 6 ones will land on Sunday, but none of the circle dates. can land on Sunday. So Tuesday doesn't work. Then we start out, then we go to Wednesday. So you add 3, Wednesday, Saturday, Tuesday. So it's kind of like a cycle. If you figure out the cycle, you'll be able to figure out the problem. So Wednesday, Saturday, Tuesday. So coupon 1, 2, 3, 4, 5. And then after Monday, it goes back to Thursday. So that's 6. And then that means none of the days ever land on Sunday, which means that Wednesday would work. So our answer is C, Wednesday. Problem number 15 states, on a beach, 50 people are wearing sunglasses and 35 people are wearing caps. Some people are wearing both sunglasses and caps. If one of the people wearing a cap is selected at random, the probability that this person is also wearing sunglasses is 2/5. If instead, someone wearing sunglasses is selected at random, what is the probability that this person is also wearing a cap? So to solve this is a probability question. So what we would do is, since the probability is 2/5 that someone is also wearing sunglasses, then that means we should multiply it by the number of people who are wearing caps, because we're talking about caps here, to find out the number of people who are wearing both caps and sunglasses, because that's a probability. Because 2/5 is the probability that they're wearing both. So if you multiply that by the number of caps on the beach, we get 14. So there are 14 people that are wearing both sunglasses and caps. Now that we got this, we have to find out the probability that the person is also wearing a cap. So that's just 14 out of the number of people who are wearing sunglasses, which is 50. If we simplify this, we get 7/25, which gives us our answer of letter B. Problem number 16 says, Chiang drives 15 miles at an average speed of 30 miles per hour. How many additional miles will he have to drive at 55 miles per hour to average 50 miles per hour for the entire trip? So with these kinds of questions, you could do guess and check or like trial and error, but it would be better if you did an equation to get a more accurate and immediate result. So the equation here is that he drives 15 miles at 30 miles per hour. So that means that basically his entire distance is 15 plus this question mark, which we can label as a variable of x. And then we put all of this, because this is his entire distance. And now that we have his distance, we can make the equation 15 miles over 30 miles per hour, plus we don't know the number of miles, x miles over 55 miles per hour, because that's the speed he's supposed to be going for the last part, equals to 15 plus x, that's total number, over his total average speed of 50. So this is the equation we are going to be using. So first of all, we need to make sure that the denominators are the same. So here we could find the least common multiple, which would be 330. So we multiply 11 to this, and then multiply 6 to that. So 15 times 11 plus 6x all over 330 equals to 15 plus x over 50. So now that we have this, we can just take out the zeros, because we don't need any unnecessary zeros in there. And then we multiply this side by 5 and this side by 33. So if we do that, we end up getting 5 times 15 times 11 plus 30x. And on the other side is 33 times 15 plus 33x. You can see that. This. Okay. And then that's the equation so far. And then I'm probably going to solve it out. So 5 times 15 times 11 is 825. And then this would be 495. If you subtract 825 from both sides, you get 30x equals to 33x minus 330. So now that you have that, now all you have to do is just divide both sides by 3, and then you get 10x equals to 11x minus 110. Subtract 11x from both sides to get negative x equals to negative 110. Then multiply both sides by negative 1 to get x equals to 110. So that means this part, which is x, the number of miles afterward is 110. So our answer is letter D. Problem number 17 states, what is the value of the product? So in order to solve this, you just have to observe carefully and see the pattern. So if you can see, there are always going to be two pairs of the number. There's going to be two versions of the number on the denominator and two on the numerator, so it'll just keep canceling out. And if you notice this pattern, you will see that everything basically cancels out. See, 2 and 2 cancel out. Same thing happening here. The 97 will cancel out, the 98s will cancel out, and then the 99s will cancel. And everything in between will, because there's going to be two of the number on the denominator and 2 of the number on the numerator, so they can just cancel out. Now, if you notice this pattern, you will see that the only numbers that we end up having left are 1 over 2 and 100 over 99. So we just multiply these, 1 over 2 times 100 over 99. We get 50 over 99, which gives us our answer of letter B. Problem number 18 states, the faces on each of the 2 fair dice are numbered 1, 2, 3, 5, 7, and 8. When the 2 dice are tossed, what is the probability that their sum will be an even number? So to solve this, we can first see that in this there are 4 odd numbers and 2 even numbers. So 4 odd numbers I'll circle in purple. That's 1, 3, 5, and 7. And then 2 even numbers, which are 2 and 8. So now that we know this, we can see that the probability, by now we should all know that an odd plus an odd equals an even plus an even equals an even, sorry. And now that we know this, the probability that the numbers will both be odd, and then we need to know the probability of both even. So the probability that they'll both be odd is 4, because there's 4 odd numbers, times 4 because we're choosing 2. And then the probability that they'll both be even is 2 times 2, since there's 2 even numbers. So this equals 16 and this equals 4. And so now we have to find out the probability of the number of possibilities for the sum of both numbers. Or the number of probabilities. So now we do this by we're doing 6 times 6, since there's 6 numbers in total, which gets us 36. So we add 16 plus 4, hope you can see this, all over 36. And if you know addition, which we all should, it is 20 over 36, which can be simplified down to 5 over 9. And that's our final answer, which gives us letter C. Problem number 19. In a tournament, there are 6 teams that play each other twice. A team earns 3 points for a win, 1 point for a draw, and 0 points for a loss. After all the games have been played, it turns out that the top 3 teams earn the same number of total points. What is the greatest possible number of total points for each of the top 3 teams? So in order to solve this problem, we have the total number of games. We need to figure out the total number of games that happened. So we do 2, because each team, they play each other twice, times 6 choose 2, which is like N choose R, which is a concept you really need to know for the AMC 8. So 6 choose 2 is 6 factorial over 4 factorial times 2 factorial, which equals to 15. And 15 times 2 equals to 30. So there are a total of 30 games that happened. Now, how many games does each team play? Well, so each team plays 2, because they play each other twice. This is a crucial part, twice. Times 5, because there are 5 other teams that they play. So that equals to 10. So each team plays 10 games. Now that we know that part, the rest of it is mostly logic, because if we have the 3 teams with the same top score, that must mean that each team did get 8 wins, because the 2 losses that they got were the first loss. So let's call the top 3 teams A, B, and C. So A has 8 wins, but its first loss comes from going against B, and its second loss comes from going against C. So these are 2 losses that they have. And this applies for each and every team on the top 3. So if we apply that technique and that method to this problem, we can figure out that each team has 8 wins. And 8 times 3, because there are 3 teams. 8 times 3, because 3 points for each win. And so 8 times 3 equals to 24. So our answer is letter C, 24. Problem number 20 states, how many different real numbers x satisfy the equation x squared minus 5, and then square that, and then equals 16. So to solve this problem, you mainly need like algebra skills, I guess. So what you do is, you know that x squared minus 5, this part, has to be either 4 or negative 4 in order for your answer to be 16. So if you know that, you can just set the equations x squared minus 5 equals 4, and x squared, this looks too small, and, x squared minus 5 equals 4, and x squared minus 5 equals negative 4. So add 5, x squared equals to 9, and then add 5 and add 5, x squared equals to 1. And so here, x could equal to plus or minus 3, and then x equals to plus or minus 1. So if this plus or minus, then that means we have the possibilities of positive 3, negative 3, positive 1, or negative 1. And that is 1, 2, 3, 4. 4 total possibilities that would satisfy this equation. And these are real numbers, so they can only be negative or positive. And so if we count this and our answer is 4, our answer would be letter D. Problem number 21 states, what is the area of the triangle formed by the lines y equals 5, y equals 1 plus x, and y equals 1 minus x? So in order to solve this problem, we need to just graph, because that is the easiest option at this point. So y equals 5. Y equals 5, our y-intercept is 0, 5, as you should know from pre-algebra. So here we can graph 0, 5, so that's here, and then just draw a line straight across. So that's our 0, 5. So that's y equals 5. Next up, we have to graph y equals 1 plus x. So y equals 1 plus x. In this case, the y-intercept is still 0, 1, and the slope is just 1 over 1, which means you rise 1, run 1. So now we just have 0, 1. That's a very big point, sorry. You rise 1, run 1. Rise 1, run 1. So using that, we just draw a line to make it relatively accurate, but it doesn't have to be perfect because it's impossible to make it perfect. And so now we have y equals to 1 plus x. Now our third equation is y equals to 1 minus x. And this one, the y-intercept is also going to be 0, 1, because as you can see, we have a 1 here. Except our slope will be negative 1 over 1. So we, instead of rising up 1, we rise down 1. So we go down 1, not rise. Go down 1 and then run 1. So we still have 0, 1. We go down 1, run 1. Go down 1, run 1. Using this, we make an equation. So here we have our equation, and then we just connect it. That was very lopsided. I'm so sorry. It is supposed to look a lot better than that. And then that is y equals 1 minus x. And so now for the grand finale. So we all know that the area of a triangle is supposed to be 1/2 base times height. So we define what our base and our height is. So this is our base, and this is our height. So if we want to find the base, we just have to calculate what these points are. So this point is about negative 4, 5, and this point is about 4, 5. So if we do the absolute value to find the distance between these 2 points, we will get our base. So 4 minus -4, because we're trying to subtract and find the total, and get the absolute value of that, and it's still 8. So our base is 8, so B equals 8. Now what is our height? Our height is this over here. So since it's 0, 1 and 0, 5, we just do 5 minus 1 and we get 4. So our height is 4. And so now all we have to do is 1/2 times 8 times 4. And that gets us 32 times 1/2, and half of 32 is 16. So the area of this triangle is 16 square units. And so that gives us the answer of letter E. Problem number 22 states, a store increased the original price of a shirt by a certain percent and then decreased the new price by the same percent. Given that the resulting price was 84% of the original price, by what percent was the price increased and decreased? So in order to solve this, we need a little equation. So to get our equation, we need to piece together the parts. So what I recommend for this is just assuming that the store is selling this shirt at $100. So that means the increased price would be 100 plus X. X is the percentage that we're trying to find here. And then that means the decrease would be 100, would be X over 100, right? Yeah, I think so. But then we need to find the new price after the increase and the decrease. So after increase and decrease. So after the price goes up and down, then it would be 100 plus X. This is your height and price times 100 minus X over 100, because you're finding the percentage of the original price using the X, equals to 84. So now that we have our basic equation, it's time to solve. So we should know the distributive property and then multiply 100 to this side. So this becomes 8,400. And then we get 100 squared. This is very tiny, sorry. 100 squared minus X squared equals to 8,400. And then now that we have that, we just solve. So we can use this to get that X squared is equal to 10,000, which is 100 squared, minus 8,400. And then solving this, you would get the answer of 1,600. So X squared equals 1,600. And if you solve this part, you get X equals to 40, or plus or minus 40, but it has to be positive. So 40% is your answer, and that gives you the answer of letter E, 40%. Problem number 23 states, after Euclid High School's last basketball game, it was determined that one-fourth of the team's points was scored by Alexa, 2/7 were scored by Brittany, Chelsea scored 15 points. None of the other 7 team members scored more than 2 points. What was the total number of points scored by the other 17 team members? So in this problem, we would need an equation. So we know that we know the number of points that A, B, and C. We're going to refer to Alexa as A, Brittany to B, and Chelsea as C. So now that we know that A equals, so let's assume that X is the total number of teams' points. So if X is the total number of points the team has gotten, then what we're trying to find here is we're trying to find D. So let's say A is 1/4 X, B equals to 2/7 X, C equals to 15, and D equals to the remaining points of the 17 team members. Okay, now that we know that, we need to find the least common multiple between 4 and 7, and that is 28, because that means that the answer of the total number of points must be a multiple of 28, so in order for the fractions to work. So now that we know this, we have X over 4 plus 2X over 7 plus 15 plus D all equals to X. So if we use our least common multiple here, we get 15x over 28 because this becomes 7x over 28 and this becomes 8x over 28. Plus 15 plus d equals x. Now x can't equal 28 because if x equaled 28, we'd have 20 over here, it would cancel out. 15 plus d would equal to 28, which is not possible because 30 plus d cannot equal to 28 since d has to be positive. So we'll try the next multiple of 28, which is 56. If we try 56, we have 15 times 56 over 28 plus 15 plus d all equals to 56. So we can cancel this out to 30 plus 15 plus d equals 56. So 45 plus d equals 56. And if we calculate this, we get that d equals to 11, since 56 minus 45 equals to 11. Which would mean that the remaining 17 members scored a total of 11 points, which would give us the answer of letter B. Problem number 24 states, in triangle ABC, point D divides side AC so that the ratio of AD to DC is 1 to 2. Let E be the midpoint of BD, and let F be the point of intersection of line BC and line AE. Given that the area of triangle ABC is 360, what is the area of triangle EBF? So in order to solve this, we first need to calculate for ABD. So if you calculate ABD is 120 because as you can see, basically AD is 1/3 of AC, which means that ABD is 1/3 of ABC. So that means that's 120. So that means DBC is triangle DBC, which is the rest of it, is just 240. And now with this equation, we can come up with the equation of DBC is equal to 240, but it's equal to BFE, because if we BFE plus FED, so I'm drawing an imaginary triangle here, plus FDC. So now that we have all of these three, you can mark, let's assume that EBF is X. Now since you need to know your postulates and theorems for this from geometry in order to be able to solve this, because this is SSS, so since they share a side and then also BE is congruent to ED, then that means this is also X. So FED is also X. So now we have 240 equals X, and this is 120 plus 2X, because this is its own part, but also adding 2X. Because as you can see, these equations will prove one another. So 120 plus 2X. And now if we solve this, we get 240 equals to 120 plus 4X. Subtract 120 from both sides. 120 equals to 4X. And so X equals to 30. So our answer, because X equals to 30, our answer should be letter B. Problem number 25 states, Alice has 24 apples. In how many ways can she share them with Becky and Chris so that each of the three people has at least 2 apples? So this question is very easy to solve if you have the right equation. So you use the stars and bars technique, which is where you have stars and you have to separate them with bars. So you group them. So if Alice has 24 apples, then each person has to get at least 2. And Alice, Becky, and Chris, Alice gets 2, Becky gets 2, and Chris gets 2. So that's already 6. So there's a required amount that there's already 6 for sure put aside. So now we have 18 left. So subtracting that 6, we have 18 left. So now that we have 18 left, we use the stars and boards equation, which is n plus k minus 1, choose k. So k is the number of objects we're dealing with that are being separated. N is the number of groups we're putting them into, and then just subtract 1. So there are 3 groups, 1 for each person. So that's 3 plus k. We have 18 objects left. Since we have to set aside 6, there are 6 required to be set aside. So plus 18 minus 1. Choose k, which is 18. So, wait, no. Yeah. So that gives us 20. Choose 18. So if we do 20 choose 18, we have 20 factorial over 18 factorial times 2 factorial. And if we fully solve this out, we cancel these out. 20 times 19 over 2, so 10 times 19, which gives us the answer of 190. So our answer is 190, which is letter C. And that is the last question. Thank you.
Don't forget to subscribe and like. If you have any questions, you can email info@agoramathcircle.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website, which is basically the end of the email but without the info and the end. So bye!